Advancements in wearable hardware have helped to facilitate close personal health monitoring. This is good for early detection and prevention of illnesses. There's a growing demand for wearables, which has generated a booming market. This market is projected to grow about 18% to $265 billion within the next 5 years. But if manufacturers keep producing wearables without taking sustainability into account, they'll end up being just another product contributing to e-waste accumulation. How can we seriously innovate in the health and wellness industry while polluting our environment at the same time? What if we could innovate wearable health products by harnessing e-waste and turning it into something that actually keeps us healthier?
Using e-waste as a resource for biomedical application is a topic that has been extensively studied and is producing promising results. With this knowledge, we have designed a unique wearable made from recycled e-waste that enhances the capability of present-day sensing technology in a sustainable way. The structural foundation of our product comes from plastic, which make up 20% of the e-waste in landfills. Recycling PT is a well-understood process where plastic from electronics are stripped, melted, and respun into polyester fibers. This process requires 88% less energy than producing it from raw materials, making a simple and cost-efficient solution. The closest layer to the skin is embedded with copper nanoparticles, also recovered from e-waste. Scientists have successfully used bacteria to extract metals, including copper, from e-waste through a process called bioleaching. Bacteria produce chemicals that leach metals from electronic scraps and bind it with or absorb the metals. While absorbing copper, this microorganism synthesizes it into nanoparticles, which will later be embedded into the product and used to sense primary biomarkers. There is an increasing commercial demands for nanoparticles like these because of their use in electrochemical biosensing and electronics. Their properties have proven to create effective biosensors for the detection of electrolytes like potassium and sodium, and amino acids like glucose in your sweat. Successfully measuring these biomarkers could mean the early detection of illnesses like diabetes. The interaction between nanoparticles and molecules produce electric signals in the band, which will be read and processed by a small microcontroller designed to send these insights to your personal devices.
The end product is a sustainable, cutting-edge wearable that can sense primary biomarkers, creating an enhanced, intimate relationship between you and your health. Popular devices like the Fitbit and Apple Watch usually rely on physiological signals like heart rate variability or ECG signals. But these physiological signals are often just secondary reactions. So the sensing of primary biomarkers, like the ones our wearables detect, may provide a more accurate way of catching imbalances or deficiencies early on. This technology provides designers and manufacturers the opportunity to innovate the wearables market while minimizing environmental impact at the same time. In the future, this design could be improved to add additional sensing capabilities. While copper is useful to detect certain markers, other nanoparticles from e-waste like gold could also be harvested. Eventually, we imagine the technology to impact more than just wearables, and for it to be applied to the expanding Internet of Things market, enhancing our experience in the home and beyond. Our hope is that the technology will help to contribute to a circular bioeconomy of sustainable products. We want it to contribute to the enhancement of the sensing capabilities of devices in the Internet of Things.
Although this cutting-edge technology is exciting, we must acknowledge and examine potential drawbacks. A major concern is that microcontroller and battery, which could potentially end up as e-waste, are currently necessary to read and transmit the changes in electrical signals. To prevent our wearables from contributing to the waste problem, we have designed these components to be simple, detachable, and reusable, so that it won't end up in landfills in the first place. Because the band acts as a sensor itself, the microcontroller can be a much simpler unit. making it easier to disassemble and recycle for future products. Considering the limited power option currently available for wearable devices, we are looking into how nanoparticles could be employed as flexible electronic circuits and energy harvesting system as a possible next step for this project. Biosynthesis of nanoparticles from microorganisms remain an exciting field of research that could impact many others.
To us, our design is not just a new wearable device, but also an innovative process. How can we begin to look at the product life cycle in a more circular way by harnessing e-waste and biodesign? Wearable devices and biometric trackers can help us to gain insights into important data and to maintain a higher level of health and wellness. We actually want this industry to continue to innovate and push the envelope so that we can be a healthier and happier society, but we want to do it in a way that doesn't contribute to the destruction of our environment.